I will give you a short overview what happens in that time, starting with this icing itself. What is it? Analyzing the impact of the natural on the natural and artificial surrounding, special on the as a mechanism on as additional loads on the overhead lines. I will give you some view on mode of collapse of the facilities. Maybe this part more for the civil engineers, but we will go quick through. And I will give you also some information about the refurbishment actions after the disaster and some words in conclusion. So, what is icing? Icing happened in the winter conditions. We must have long time of temperature in the space under the zero. So all surfaces became undercooled. Under the temperature of the surface will become under the zero. And in such condition, some layer of warm, wet air run into the space. Here in this, here you can see on this map the area of Slovenia. We are influenced by the Mediterranean, how to say, front, which brings us warm air in the case of the winter conditions. So, in that case, you can see here the temperature cross sections through the cross section through the height. The warm air. Here, in these are the temperature are over was in this level positive, and at the participation in such conditions normally are in upper level. It's snowing. Here became raining. And here, there are temperatures also under the zero, became raining, but with the water, which is very near to zero. And combined to the undercooled surfaces and this water, each drop immediately became ice. And it depends then on the time of this event, how many ice will collect on the surface. That means the thickness of the ice depends on the normally of the duration of the event. In our case, we had 1 week similar conditions, and it produced such results that we can speak about the natural disaster. We can see results also here on this map of the forests. You can see the map of Slovenia. And with these colors, you can see how many trees were damaged. And here, illustration of this impact. Here you can see practically Hiroshima picture in the forest, caused by ice. The next influence was on the traffic, on the railway. We have connections, direct railway from the port of Koper to the Ljubljana and to the Middle Europe, so a very important railway, which was out of order because also the network, electricity network of railway fall down. And we used few days to find the right old diesel machines to start operated the railways once more. And roads were also closed by fallen trees. Not highways, but all other roads were closed because a lot of trees fall down. And especially, what is my point, the electricity. Here you can see the transmission network of high voltage lines, 400 kV 220 kV, and locations where the damages were come out. And there are some lines, especially this from Beričevo, this is Ljubljana, to the Divača, it suffered most. 55 towers fall down in the range of 200 tons, and altogether, all lines with 28 towers and 420 tons. Altogether, about 10 million euros of damages. The second is the distribution lines, much more affected. It was affected about 1,600 kilometers of the lines. The range of damage is 70 million, says. And if you can see from this table, about 16,000 pools, different pools from steel, concrete, wood, was damaged and have to be replaced. Why happened this? Few words. The behavior of the overhead lines depends on the behavior of conductor. Conductor has a form of chain, which is expressed by this equation. Expression of chain, and in this equation we have this parameter MC introducing additional load. And what is important, what I would like to say, in this additional load is defined by standard. Each country has own standard because of the local conditions. This F is very important for design loads. And here, if I illustrate this on this line, I told you about Beričevo Divača. The design factor that was in the middle of 70s was taken in different line sections, depends on locations, in this range. And what happens in 2014? This, you can see, 12 times overloaded. There are not structures which will survive such overloading. Maybe some pictures which illustrate how the towers fall down. We speak about the towers in the shape of the letter Y, type Y for 400 kV, and another type spruce. This is for 220 and 110 kV. And what is interesting, comparing how they were demolished. Y towers fall down, were damaged, and the spruce, at the same condition, I would say here, survived. This is some kind of lesson for structural engineers, how to find the right form of the towers too. Here are some other modes of how the spruce towers fall down completely or were broken somewhere in the middle of the body, or the consoles fall down. Another one, some details, such interesting things. The steel was ripped like paper. About foundations, this was the best solution for us. The foundation haven't been damaged, so we can put on old foundation new steel structure. Another one is this one, where only the head of this foundation was damaged, and the worst was this, where the foundation will pull out. Conductors and equipment. The tower survived, the conductors and as isolators were damaged. And what happened after that? Refurbishment actions started immediately, but we have a lot of problems because the lines crossed the very extensive wooded area. Access roads were impossible. And much harder was to move through the forest because some towers are not near to the roads. So that there were very dangerous conditions for work. Normally that emergency assistance to the population were taken immediately. Army and fire brigades were engaged, bringing very different aggregates for producing electricity, for bigger aggregates for the whole villages and smaller for some houses. And what is interesting that we first time asked for assistance, for help, the civil protection mechanism of European Union. And on this table you can see how does it work. We get 72 aggregates through this through this way, together with the 640 staff supported work of these aggregates for this terminus for 3 weeks, 1 month paid. Then it was given back. Then another way of help were bilateral assistance from Austria, Italy, Croatia, and so on. We get all together 100 aggregates. And it is interesting that 4 of them from Italy were given as a donation, and 10 from USA also as donation. Refurbishment work started normally immediately where was possible and reasonable. Normally because the whole story was 1 week practically very dangerous. The documentation, the basis for immediate for these actions were original documentation and reports which come from the field. And I would like to stress that all actions were finished before the terminus deadlines which was signed in the contracts. So that means that the people who were engaged and institutions are written here work with the heart. That is the story. Maybe only this we know this event has a stochastic and is stochastic, and that we do not know when we will be happen again, and we have to expect in the future also some similar events. So also in the world is this known, very well known, and there are studies who would like to find the way how to manage the icing, how to manage the additional loads in the way of 2 ways are. First are to find the right method of de-icing, and or how to find the method anti-icing. That means that the ice will not catch the conductors, some kind of chemical things and so. That is only some kind of illustration, and maybe more in the discussion. Thank you.